2.5 Density and the particle theory of matter. In this big idea, you have observed that different substances have different densities when at the same temperature. It is time to investigate what happens to the density of a fluid when the temperature of the fluid increases or decreases. The particle theory of matter can help us to understand that if a given sample of a substance stays at a constant temperature, the energy of particles stays the same. Because the energy of the particles stays the same, they will occupy the same volume. Density does not change as long as the temperature stays the same. According to the particle theory, the particles begin to vibrate when energy is added to a substance. As a solid changes to a liquid and eventually to a gas, the particles vibrate and move more rapidly. How does this affect the density of a substance? What would happen if the fluid being heated were a gas? What would happen if energy were removed from a fluid by reducing the temperature? The volume of a gas increases when it is heated and decreases when it is cold. What happens to the density of the gas? In the following video, you will investigate the effect of temperature on the density of fluid. Here I'm going to ask you to either pause this video and come back, or finish this video and then go and watch the balloon experiment video. There are some questions that go along with that that are listed here, but I'm going to continue to read the next little bit and finish off. As particles move more rapidly, the space between them increases. This can cause two things to happen. First, the volume increases because the particles need more room to move. The volume increases, but the number of particles does not, meaning that the density decreases. Unless water is colder than 4 degrees Celsius, warm water rises above cold water. If you swim in a lake, you may have noticed patches of warm water on the surface and cooler patches of water at lower depths. So if you're swimming in a lake in Saskatchewan, oftentimes the water that is closest to the surface, or even in a deep outdoor pool, the water closest to the surface is warmer than the water that is closer to the bottom, or closer to the bottom of the pool or the bottom of the lake. So we have some questions here. The first one is to use that particle theory of matter to describe what happens to the density of a substance when it cools. So what happens to all those particles when we cool something down, and how does that affect our density? The second question is, most substances increase their density as they move from a gas to a liquid to a solid. Water is an exception. It actually becomes less dense as it freezes. Without measuring, how would we know that ice is less dense than water? So what could I do with ice and water to prove that ice is less dense than water is? Now we have a little bit of an info bit here, and it's about Galileo's thermometer. So the picture at the right shows a different kind of thermometer. It is Galileo Galilei's thermometer, or thermoscope. It was first invented in the 1590s. The initial densities of the bulbs are the same. The weighted tags are then attached, indicating a temperature for each bulb. Those showing higher temperatures have lower densities, and those showing lower temperatures have higher densities. As the temperature of the water rises, its density decreases. The bulbs of lower density rise, and those of higher density sink. The bulb that has the same density as the water just floats just below the surface and indicates the temperature of the water. So depending on how warm or cold it is, these little colored balls, little glass balls inside, they move up and down based on their density. And so we know what temperature it is because each of them have a little tag that has a temperature. So we know what the closest temperature is by looking at the ball that is closest to the top of the water, to the surface, and that is approximately the current temperature in the space that this thermometer is located in.